These are your x-intercepts, y-intercepts, and zeros notes, and we're going to do it all algebraically. So in the past, what we have done for x-intercepts and y-intercepts is actually look at a graph to see where the x and y-intercepts are. So your y-intercept is always on the y-axis. So here it is, your y-axis, and it's right there at what we can see is 6, a positive 6. So your y-intercept is 6. When you're graphing in slope-intercept form, that's the point we're always looking for to start at so that we can build our slope off of that. So I kind of skipped ahead here. Y-intercepts can be found on the graph on the y-axis. Goes in that blank. Now your x-intercepts, I'm going to switch colors so we can see that a little bit better, are always found on your x-axis. So this horizontal bar is your x-axis, and we can see right here is our x-intercept, that is -4. So you notice that the whole coordinate is the x-intercept and the whole coordinate is the y-intercept. So that is on your x-axis. And then zeros, do you remember what they are the same thing as? Those are the exact same as your x-intercepts. So if I asked what the zeros of this graph were, this one right here, you would also tell me -4 for that one. But sometimes we don't have a graph and we still want to know our x and y intercepts or even our zeros. And so what we have to do is do it algebraically. We just got to solve a little equation to do so. So the x-intercept is the value of the equation when y is 0. Let's make that make a little bit more sense to you real quick. So here's a fake graph, and here's my x-axis. And I know I'm going to find any x-intercept along this axis. So it doesn't matter what point I'm looking at. I'm going to have an x value, so I'm going to have some sort of number for the x value, but it's not going to go up or down any, so we're going to say 0 for the second part. So that's what we're really talking about there. Our y value has to be 0 for an x-intercept. For a y-intercept, the opposite is true. So a y-intercept is going to hit that vertical bar somewhere up here, so any one of these points, doesn't matter what, I'm going to have, it's not going to go over left or right any, so my x value is 0, but my y value will have a number. So the y-intercept is the value of the equation when x is 0. So if you want, you can organize this in a intercept table, just like I've shown you over here. I find that very easy to keep all my work straight when I do this. So that one right there. So look what that table tells you. So it's just like a little t-chart. You could draw it as simply as this, x, y. You want to plug in where y is 0, and you want to plug in where x is 0. And then we're just going to solve for whatever value this is and whatever value this is by plugging into the equation they gave us. So if I'm plugging into the y one here, so I'm getting a number in this x spot, that is the x-intercept because your y is 0. If I'm plugging in a number right here in this y spot, then and the x is 0, then you know that's your y-intercept. So let's try this out. I've given you plenty of space to do your side work over here, and we're going to make a summary of everything down here. So my equation is 2x plus 7y equals 14, and I want to find the x and y intercepts. So the first thing I need to do is I need to plug in that y is 0. See how that happens? You can see that the y value on the table is 0. So I'm going to say over here, to find the x-intercept, I need to say that 2x plus 7y, except I'm not going to say y anymore, I'm going to say 0, equals 14. So we're plugging in half the coordinate to force it to tell us the other half of the coordinate. So I'm going to do some quick PEMDAS. 7 times 0 is 0, and 2x plus 0 is still 2x. So you notice that entire part of the equation just disappears really, and you can start skipping that work as you see it. So 7 times 0 is just 0, and adding 0 doesn't change anything. Now you've just got a quick one-step equation. Divide by the 2 to get rid of that multiplication, and you've got x is equal to 7. So I'm going to go over here, and x is equal to 7. So I know my x-intercept is 7, and we know one more thing is 7, and if you can find it real quick, there it is. Your 0 is the same thing as your x-intercept. Now let's go solve for our y-intercept. So for my y-intercept, remember again, the picture says that our x value needs to be 0 in order for it to lie on the y-axis. So I'm going to say 2 times 0 this time. So again, I'm going right back up here, saying 2 times 0 plus 7y is equal to 14. Now it's really easy to tell which one you're solving for. If you're solving for the y-intercept, you still have a y in your equation. If you're solving for the x-intercept, you still have an x in your equation. So you know if you plugged in 0 in the right spot. So 2 times 0 is 0. 0 plus 7y is just 7y. And then that's going to equal the 14. Notice I'm just bringing that down. So I'm going to divide by my 7, and y is equal to 2. So I'm going to fill out my table up here, which tells me that the y-intercept is 2. On the back page,